This presentation was prepared as part of the HAP 361 course on health databases, taught by Abdul Hafeez, Ph.D. at George Mason University, Department of Health Administration and Policy. Today, I'll be discussing our SQL Teach 1 project, focusing on SQL for predictive models. My name is Mitchell Cheek, a senior at George Mason's College of Health program, and I'll guide you through how SQL can enhance predictive analytics. Let's dive in. Our objective today is to explain the importance of SQL in building predictive models and its application in predictive analytics. Predictive modeling has become a cornerstone in various fields such as finance, healthcare, marketing, and more, enabling organizations to forecast future trends and make informed decisions. We'll cover an overview of predictive models, the basics of SQL, SQL techniques for predictive models, and how these were implemented in our project. By the end of this presentation, you'll have a comprehensive understanding of the critical role SQL plays in developing robust predictive models and the benefits it offers in predictive analytics. Predictive models use statistical techniques and algorithms to forecast future outcomes based on historical data. These models are essential for making data-driven decisions, identifying and mitigating potential risks, and optimizing operations and resource allocation. For instance, businesses use predictive models to forecast sales, enhance customer satisfaction, and improve inventory management. Predictive modeling typically involves several key steps. First, data collection is crucial as the quality of data directly impacts the model's accuracy. Once the data is collected, it is cleaned to remove any inconsistencies or errors. Feature selection and engineering are then performed to identify and create the most relevant variables that will influence the model's predictions. The next step involves selecting an appropriate algorithm and training the model using historical data. Finally, the model is validated and tested to ensure its accuracy and reliability. The predictive model can then be used to make future predictions, providing valuable insights for decision-making processes. Predictive models can be applied in various domains. For example, in healthcare, predictive models can forecast disease outbreaks or patient readmission rates. In finance, they can predict stock prices or credit risk. The versatility and power of predictive models make them indispensable tools in today's data-driven world. SQL, or Structured Query Language, is fundamental for database management and manipulation. It's the primary language used to interact with relational databases, allowing us to perform tasks such as retrieving, inserting, updating, and deleting data. SQL's versatility extends to functions for data aggregation, filtering, and joining tables, which are essential for preparing data for predictive models. With SQL, we can efficiently handle large datasets, perform complex queries, and manipulate data to extract meaningful insights. SQL's structure and simplicity make it an invaluable tool for data scientists and analysts working on predictive models. Its wide acceptance and use across various industries underscore its importance in the data management and analytics ecosystem. For example, when we need to retrieve specific data from a database, we use the select statement. If we want to add new data to a database, we use the insert into command. To modify existing data, we use the update command. And to remove data, we use the delete command. These basic commands, along with others like join for combining tables, form the foundation of SQL managing and preparing data for predictive models. The select statement is used to retrieve data from a database. It allows us to specify which columns we want to retrieve and apply conditions to filter the data. For example, if we want to retrieve the names and ages of all users who are older than 25, we would use the following query. This query selects the name and age columns from the users table where the age is greater than 25. The insert into command is used to add new data to a database. It allows us to insert new records into a table by specifying the columns and their corresponding values. For example, if we want to add a new user named John who's 30 years old, we would use the following query. This query inserts a new record into the users table with the name John and age 30. The update command is used to modify existing data in the table. It allows us to update specific records based on given conditions. For example, if we want to update the age of a user named John to 31, we would use the following query. This query updates the age column to 31 for the record where the name is John. The delete command is used to remove data from a database. It allows us to delete records that meet certain conditions. For example, if we want to delete the record of a user named John, we would use the following query. This query deletes the record from the users table where the name is John. The join command is used to combine rows from two or more tables based on a related column between them. It allows us to create comprehensive data sets for analysis. For example, if we want to retrieve the names of users along with their order dates, we would use the following query. This query selects the name column from the users table and the order date column from the orders table, where the ID from the users table matches the user ID from the orders table. SQL plays a critical role in data pre-processing, which is essential for building accurate and predictive models. Data pre-processing includes cleaning and transforming raw data. For instance, we can use SQL to update missing values in our data set. This command replaces null values with a specified value, ensuring that our data set is complete and ready for analysis. Feature engineering is another crucial step where we create new features from existing data to improve the model's performance. For example, we can create interaction terms or polynomial features. This command generates a new feature by multiplying two existing columns, which can help capture interactions between variables. Data aggregation involves summarizing data to derive insights, such as calculating averages or sums. This command calculates the average value for each group specified by the column name, helping us understand trends and patterns within the data. Data splitting is about dividing the data into training and testing sets, which is vital for model validation. This command allows us to select a subset of the data for training or testing purposes, ensuring our model is validated on different data than it was trained on. Beyond basic data pre-processing, SQL can be used for more advanced tasks. One technique is using window functions for advanced calculations without grouping the data. Window functions allows us to perform calculations across a set of table rows that are somehow related to the current row. This can be useful for computing running totals, moving averages, and other cumulative calculations. Creating time series data for trend analysis is another advanced technique. This command truncates the timestamp to the day level and sums the values for each day, enabling us to analyze trends over time and make time-based predictions. We can also leverage SQL to perform exploratory data analysis by generating summary statistics. EDA involves summarizing the main characteristics of the data, often using visual methods to uncover patterns, spot anomalies, and test hypotheses. Implementing predictive models with SQL involves several well-defined steps. First, we need to define the problem we are trying to solve and set clear objectives. For example, a business might want to predict customer churn, forecast sales, or identify fraudulent transactions. Clearly defining the problem helps in determining the right approach and selecting appropriate algorithms. Next, we collect and pre-process the data, including cleaning and transforming the data using SQL techniques. This step ensures that the data is accurate, complete, and ready for analysis. Engineering follows, where we create new features that can enhance the predictive power of the model. For example, creating interaction terms, polynomial features, or aggregating the data into meaningful summaries. After pre-processing and feature engineering, we aggregate and analyze the data to extract useful insights. This step helps in understanding the relationships with the data and identifying patterns. After pre-processing and feature engineering, we split the data into training and testing sets to validate the model's performance. This step is critical to ensure that our model generalizes well to new unseen data. Finally, we build the predictive model using appropriate algorithms and evaluate its performance using metrics like accuracy, precision, and recall. We may iterate through several models, refining and optimizing them to achieve the best results. Each of these steps is essential for developing a robust predictive model that can provide valuable insights and support decision making. To illustrate the practical application of SQL and predictive modeling within the healthcare sector, let's look at a case study. A hospital wanted to improve its patient care by predicting readmission rates to optimize resource allocation and reduce unnecessary readmissions. By using SQL, they were able to collect and pre-process patient data, including demographics, medical history, and previous admission details. Feature engineering was performed to create new variables such as the time since last admission and the complexity of the medical condition. Data aggregation was used to summarize patient data and identify patterns. The data was then split into training and testing sets, and a predictive model was built to forecast the likelihood of patient readmission. This model helped the hospital staff identify high-risk patients and provide them with targeted interventions and follow-up care. The results showed significant improvements in patient care and with optimized resource allocation and a reduction in readmission rates. This case study demonstrates the practical benefits of using SQL for predictive modeling in the healthcare sector, leading to a better patient outcomes and more efficient hospital operations. While SQL is a powerful tool for predictive modeling, several challenges need to be addressed. One major challenge is ensuring the quality of the data. Poor data quality can lead to inaccurate predictions, so it's essential to implement robust data cleaning processes to ensure that the data is accurate and complete. Another challenge is validating the accuracy of the predictive model. This involves using techniques like cross-validation to evaluate the model's performance and ensure that it's not overfitting the data. Cross-validation helps in assessing how well the model will generalize to new unseen data. Another significant challenge is integrating SQL with other analytical tools and platforms. Ensuring seamless integration and compatibility is crucial for efficient data processing and analysis. This can be achieved by using APIs and data connectors that allow different systems to communicate and share data seamlessly. By addressing these challenges, we can build more reliable and accurate predictive models that provide valuable insights for decision making. It's important to continuously monitor and refine the models to maintain their accuracy and relevance over time. In conclusion, SQL plays a crucial role in building predictive models. By providing powerful tools for data pre-processing, SQL's ability to handle large data sets, perform complex queries, and clean data ensures that the data fed into predictive models is accurate and reliable. Proper data pre-processing with SQL enhances the quality and performance of predictive models, leading to more accurate predictions and better decision making. Feature engineering and data aggregation are critical steps in predictive modeling, and SQL provides robust capabilities for these tasks. By leveraging SQL, we can create new features, summarize data, and derive insights that improve the predictive power of models. Integrating SQL into predictive analytics workflows significantly enhances data-driven decision-making processes. Thank you for your attention. I hope this presentation has been provided valuable insights into the role of SQL in predictive modeling. I now welcome any questions or discussions about our project. Your feedback and inquiries are valuable, and I look forward to addressing any thoughts or concerns you may have. Please feel free to share your thoughts or experiences related to predictive modeling and SQL. If there are any concepts you'd like me to clarify, or if you'd like any additional examples, I'm here to help. Your feedback is crucial for continuous improvement, so I encourage you to voice any suggestions or ideas you may have. Let's engage in a meaningful discussion and make the most of this opportunity to learn from each other. Thank you.